Okay, today we are doing problem 450, delete node in a BST. So we are given a root node reference of BST and a key. Delete the node with given key. Return the root node reference possibly updated of the BST. Basically, deletion can be divided into two stages. Search for a node to remove if the node is found in the node. No shit, brother. Oh my days, who wrote this tutorial? Oh, they are unique, valid binary search tree. Okay. I mean, we can find it in login, but then what value goes in? Next closest value. Which I don't remember how it was found. I mean, the straight up easy solution in linear time. That's interesting. Because let's say there is like, instead of this 4 there is 4, 5, or this is like 10, 11, 12, and then there is 4, 5, 6. So then how would we place this node here? I'm not really sure, to be honest. Well, if it has no descendants, we just erase it. If it has a single descendant, we put the descendant there. And if it has both descendants, right, then we need to do some stupid rotation. And the stupid rotation will work like this. We put this node here, but now potentially we have 3 children, because what about this? Well, we keep that there, and now we have to move. Nah, we cannot do that because the smallest one from this subtree has to go there, which I mean, that's tough to implement, to be honest. I mean, you have to, because when you have a full tree and you cut this, you need to put the smallest value up there from the right tree, which you find by going right and then all the way to left. Okay. It's not that hard, actually, but this will take me way longer. Okay, so basically find node 0 children erase one child, replace it with child, two children, because let's say I cut it out, two children, we go right, smallest larger value, which can be found by going right and then as left as possible if the red blood cement has a right child. Replace red blood cement with its right child. Okay, only thing that sucks is that we don't have back pointers. Okay. While node val don't equal key, if node val key node else, like that, and we finish at the node. If node left and not sure how to get the previous node, to be honest. So we found the node which needs to be trashed, right? And then okay, left val don't equal key var node. Okay, so print node val var val. Classic Leetcode 3 problem. Okay, that's fair. Okay, so if not node left and not node right, par if par left and par left, val key return, then par left non if par right and otherwise par right equals none. Okay, if not node left, then it's the right node. If par left and par left val key, then par left node right if par otherwise par for xy node left node right node right node left and if not x, meaning that so this is the one child, zero child, one child, and now so if the node doesn't have the left child, then we assign the right child, right, return root, else if par left and key par Actually, yeah, that's what I wanted to avoid. Like that. I think that works. So this will not work, of course. So let's do a new case and let the key be 2, right? Let's see, it should work. Okay. Now let the key be 6. That should also work. Okay. If I remove 4 and change key to 3, that should also work. Okay. And now if we have both children, then 11, 12, then our 4. Wait, so it has child 3, 11, right? Then 3 has 2, 4, and 11 has now 12, and then 2 has now, and 4 has, this should be 5, and this should be 4 and 6. Okay, nice. So 4 should go there. Two children, right? So note. Now we have n is note, right? If not n left, then we just wanna do n node val is equal to n val, node right is equal to n right, and that's it. Otherwise, we need to go as left as possible. So we take the leftmost one. Now we also need the parent. So basically, parent is n, while n left is n left, right? And then we go to the end of the chain and we have the parent. And now what happens? Well, here is what happens. Node value is equal to n val, right? And then parent left is equal to node right, and that should work, I think. Great. Okay, let's try to submit. 5 test cases wrong. If know the root, let's see. So if left child is not none, then we want to do this. If node return y should work. Okay. That was not that painful, but it's midnight and I wanted to be asleep, but whatever. So title is next so first find the node with if the tree does not have a, let us first find the node with the value key, let it be a node. There is no such node. We can remove we can return the root and be done. If there is such node, we have 3 cases. It does not have any children. It has exactly 1 child. It has both children. Not sure why it's so big. If node does not have any children, we simply delete it. We simply delete the pointer to it from its parent. If node has exactly 1 child, we simply overwrite the pointer to node from its parent to its only child. If node has finally the situation becomes slightly amusing if node has both children. Maintain the BST. We look for the smallest larger value, i.e. the smallest value in the subtree, which we can find by going to the right child and then going left to the left child of the current node until we can. This node should replace the node, but what about its children? Well, this node, let's call it n. Well, we by definition, if there are any, there can only be the right child, because we went to the leftmost one. Therefore, we simply move the right child. We change the pointer of parent of n from n to right child of n. Note that to have access to parents of nodes, we simply maintain the previous nodes. Nodes 2, the found node is the if node is root and it has 0 children, we return none. If node is root and it has 1 child, we simply return the child. O log n, where n is the size of the BST, since we just go down at most the whole height of the tree, which is O log n in a BST. Since we only use a couple of extra variables, couple of extra pointers to some nodes. Okay, so that was doable. Goodbye.